Hello everyone and welcome to the lesson of physics. So this is the second video for the first chapter, physical quantities and units, and in this one we're going to study the topic, let me scroll it down, use of SI units to check the homogeneity of physical equations. And this topic is very frequently linked with the previous one, in which we have to derive the base units of some of the physical quantities. Alright, so in simple words, all we can say is if you find out the base units on the left side of the equation, that should be equal to the base units on the right side of the equation. Alright, I'm saying base units because it would be easy for you to compare the units then. I mean, it might be something like this. For example, on the left side of the equation we have Newton's second, and on the right side of the equation we have kilogram meter per second. Now if you want to compare it like in this form, it might be difficult for you, although you might have studied in O-level physics that Newton second, we can measure momentum in Newton second, we can measure impulse in Newton second, we can measure impulse in kilogram meter per second as well. But it might be difficult for you to compare if the two sides are equal in terms of unit or not. So that's why we'll be converting these units, the derived units, into base units as well. So Newtons, like we did in the previous lesson, Newton was equivalent to kilogram meter per second square times this second as it is equals kilogram ms minus 1. If you sort out the left side, this would be kg ms minus 1, and that equals to kg ms minus 1. Now once the equation has the units in terms of the base units, now it's very easy for you to compare, and you can safely say that whatever this equation was representing, this equation is homogeneous equation, means the units on both sides are same. So the rule number one would be we write the units of all the physical quantities in the equation in terms of the base units. Okay, this is the very first thing. Anyway, if you have two quantities and you need to add or subtract two quantities, then they must have same units. For addition or subtraction, the two quantities must be having the same units. Only then you can add the two quantities. Now what are the examples? Think about it. 5 seconds. Okay, so you measured a time interval between two events and the answer was 5 seconds. In this time, in this quantity 5 seconds, if you try to add 3 kilograms, that does not make any sense. I mean, what would your final answer be in? Would it be seconds? Would it be kilograms? Would it be a combination? No, the thing is, it would not make any sense to add two different physical quantities. Alright everyone, so here you have the first example in which you have to prove or you have to show whether or not the equation is homogeneous. So let us do the first step. They have given you these this data as well. Time, t represents time, which would be measured in seconds. L represents length, which would be measured in meters. G is acceleration of free fall in the base units, meter per second square. So in the first step, what you have to do is to write all these physical quantities in the equation in terms of their base units. Okay, this is the first step, in terms of the base units. So what is the unit of time? It is the SI unit. SI base unit of time is seconds. Alright, time is a base quantity. It has a base unit, but the standard one is seconds. Then the next thing, 4 pi square. What is the unit of 4 pi square? The answer is no unit. It's a constant number. It would give you a value, a numeric value. just a numeric value. So for all the constant numbers there would be no unit, so you can ignore it for a while. Alright, so it's not even there. What is the unit of length? Meters. Divided by what is the unit of acceleration of free fall? ms minus 2. So you write ms minus 2 here. What do you do afterwards? Well, what you can do is you can simplify the equation, so you'll be left with s equals, you see, meters cancelled away with meters, and you're left with 1 over s minus 2, or you can write it as s equals to s squared. Now the units on the left side of the equation are not equal to the units on the right side of the equation, so this is not a homogeneous equation. This is a non-homogeneous equation. Let us try another example. Okay, if that is not clear, let us try another example. So they give you this equation and they ask you, is this equation homogeneous or not? Alright, and all the physical quantities are just the same that we mentioned previously. T is time, L is length, G is acceleration of free fall, 2 pi is a constant number with no units. Let us insert the base units of all these physical quantities. For time we have seconds. 2 pi would be ignored. Like I said, the constant numbers, you just forget about it for a while. Then you have length in meters divided by acceleration of free fall, ms minus 2, and then square root of it. Okay, in the next step you do some of the cancellation, like meters cancelled away with meters. You'll be left with 1 over s minus 2, which can be written as s squared under root of it. Then if you take square root on the right side, you will be left with s only. Now for this equation, the units on the left side were second and the units on the right side are also seconds. So you can safely say that yes, this is a homogeneous equation because the units on both sides of the equation are same. So this is how we can check homogeneity of an equation. Another example. Example number 3. Alright, and by the way, all the examples that I'm solving here, these examples are from the past papers. These are the equations that they generally give you to check for homogeneity. So here we have another example. S square equals to ut plus 1 over 2 gt square, or let's keep it at square. And for the data they have given you, s is the distance, t is time, u is speed or velocity, a is acceleration. Alright, so let us insert the base units of all these physical quantities starting from the left hand side. So on the left side we have s squared, means square of meters. Okay, because s represents the distance, the standard unit of distance is meters. Then you have u stand for speed, so it would be meters per second, ms minus 1. That is being multiplied by time, the standard unit of time is seconds, plus 1 over 2 constant number, it would be ignored because it has no unit, followed by acceleration. For acceleration we have ms minus 2, followed by the square of time, so it would be seconds square. In the next step you have to simplify the equations. M square equals to this term would be m. You will be left with m only here. Okay, how? Because meters, you're left with meters, but the thing is s minus 1 and s, these two would be cancelled out. you have s minus 1 plus 1. You're left with s power 0, which is 1. So nothing from here. And matter of fact, at this step, till this step, you should be getting your answer that this is a non-homogeneous equation. But we'll solve, let us complete it anyway. Plus ms minus 2 times s square. Okay, ms minus 2 times s square. Then s minus 2 and s minus 2 would be cancelled out, and you'll be left with m plus m. So you add two quantities with the units meters, your answer would also be in meters. On the left side, you have meter square. On the right hand side, you have meters. So this is a non-homogeneous equation. Okay, so boys and girls, this is the next question, and we have question number 4. There's a variation in it. In this question, they have asked you to show the gamma has no unit. You have to show that this alphabet here, this letter here, has no unit. In the question, they have specified the quantities as well. For example, they have told you V stand for speed, P stand for pressure, rho stand for density. And you have to show this thing, gamma has no units. What is the first step? You have to make gamma the subject. In order to make it the subject, you can take square on both sides. You'll be left with, so you can get rid of the square root on the right side. So you'll be left with gamma p divided by rho. Now if you want to make gamma the subject, then gamma equals to v square times rho divided by p. P stands for pressure here. That is given in the question itself. Okay, in the next step, you have to insert the base units of all these physical quantities. This thing has to be proved that it has no units, so forget about this one. You insert the base units on the quantities on the right side. V stand for speed, so it would be meter per second, but square of it, because you have v square multiplied by. This is the symbol for density. The SI units of density were base in terms of base units kg m minus 3 divided by. What did we have for pressure? We studied that in previous lesson, that pressure can be expressed in terms of base units as kg m minus 1 s minus 2. Alright, we studied that in the previous video. If you don't know how do we do that, you can watch the video part 1. Alright, chapter number 1, part 1. Pressure was written in the form of force and area. Force was converted into form of mass, acceleration, and we inserted the base units and we solved it. Or you can also use pressure equals to rho g h, and then you can insert the base units and come up with this one. Then in the next part, you simplify these things, so you'll be having meter square s minus 2 because you open the square, multiply by kilograms m minus 3 divided by kilograms m minus 1 s minus 2. Let us do some of the cancellation. So kilograms straight away cancelled out by kilograms, s minus 2 cancelled away with s minus 2, and meters are also being cancelled out, but it may not be very clear to you. Let me write down meters. So you'll be left with m2 into minus m3 divided by m minus 1. Let us apply the laws of indices. So you'll be having 2 minus 3 plus 1. So 2 plus 1, you get 3. 3 minus 3, you get 0. M raised to the power 0. What are you left with? You're left with 1. So the final answer on the right hand side is 1. Final answer on the right side is 1. Now 1 is a constant number and it does not have any unit. Alright, 1 is unitless. This thing is unitless, and this is what they asked you to prove, that gamma has no unit. So From here we can conclude that the final answer on the right side was 1, which is a unitless quantity, so gamma would not be having any unit whatsoever. Let us treat it for the first case in which they ask you to find the unknown power of an expression or of a quantity. All you have to do in this one is to compare the powers on both sides of the equation provided they have the same units. So compare. Let us start off with an example. The first one example is t square. Question number 1. The first one is t square equals to 4 pi square L over g, 4 pi square L over g raised to the power x. So you need to find the value of x here. So x represents an exponent and the exponent can be 1, 2, 3, 4, 5. So what do we do in this one? Once again, the very first step is ignore the constant. Constants do not have any units. So you ignore the constants and you insert the base units of all the quantities that are there in the equation. So let's start off with this one. Time square would be second square equals to 4 pi square. You just ignore it for a while. Length would be in meters divided by g represents acceleration of free fall, ms minus 2. All right, the quantities they mention in the question, like what does each and every letter represent? Raised to the power x. Let us now simplify it and you'll be left with s square equals 1 over s minus 2 to the power x, and then you can further simplify it. You'll be left with s square equals to, now 1 over s minus 2 can be written as s square raised to the power x, and from here you can write it as s square equals to s raised to the power 2x. Now what is the base? The base in this equation is s. On both sides the base is now same. If the base is same, you can equate their exponents as well. So what we can do is we can put 2 equals to 2x. Right, so from here we go to this step. 2 exponent on the left side equals 2x, that is exponent on the right side. Now x equals to 2 divided by 2, which is 1. So the final answer for this one is 1. The power of the x here would be representing 1. The key point, once again we covered it already, in correct equation for two quantities being added or subtracted, they must be having the same units. Okay, so this is a concept, the very same concept that would be used in the sample question. So whatever the statement is, you're provided with this equation, and a is the internal radius. Radius means it is a length between two specific points. In any way, the base unit would be meters, and p and q are constants. Okay, they must be having some units. Which row gives the correct units for p and q? All right, so these are the constants, but these constants would be having some units. This is what we get from the options as well. So we have to find the units of p and the units of q. In the first step, what you can do is ignore the constants. Like I always say, ignore the numeric value, ignore the numeric constants. Sine theta, for example, the angle was 10 or 30. Let's say sine 30. Now what is the answer for sine 30? You get 0.5. followed by, is there any unit? No, it's not. So you get only 0.5. You get a number. A number has no quantity, has no unit, so you can ignore sine theta from there. And the rest of the equation you can sort it out. You can multiply L with this bracket, and you'll be left with 3 times length plus a square L divided by P equals to QT square. And no sine theta there once again. You know the reason. In the next step, what you can do is you have to use the very same pointer that I wrote previously. So what would be the units of 3 times length? You see, L is the length here, L is the distance here. So distance would be measured in meters. And for 3 times of length, the unit would be meters. Okay, so let's say the length of a box is 5 meters. And you're trying to find 3L. So 3L would be 15, but the unit would remain same. The unit would once again be meters. Now, as we know that one of the term in this equation has the unit meters, then all the other terms in the equation has to have the same units, because only then we can add them. Otherwise this thing would be broken down. The concept would be broken down that in order to add two quantities, they must be having same units. So the unit of all of it and the unit of all of it has to be meters. Okay, only then you can add them. Now what you can do is you can compare both of them one by one. So what I can do is the unit of a square L divided by P, the unit has to be meters. The unit of this thing has to be meter. Only then this thing can be added in the previous term. Then in the next step, they told you that A is the internal radius. Radius is the length of the meter. A unit would be meter squared times meters divided by P equals to M. Then you can sort it out to find the value of P. You see, M cube equals to MP, and one of the meter would be divided on the other side, and the unit of P would be meter square. And if we take a look at the options, we have 3 options for which the unit of P is meter square. So we cannot choose the right answer for now. We'll need to find the unit of Q as well. So we apply the same property that the unit of this thing should also be meters. So once you are adding two things, for example, 3 meters plus 2 meters equals of 5 meters. You see, you added two things. They were added because they were having the same units, and their final answer also has the same unit. It cannot be something like 2 meters plus 3 meters equals to 5 kilograms. I mean, that wouldn't make any sense. So that's why we can say that the unit of QT square, Q times T square, should also be meters. Q written as Q. Alright, you can't do anything with it, so you write Q as it is. The unit of T is second, so unit of time would be second square equals to M. You shift seconds on the other side, it would be divided M over S square, or you can write it as MS minus 2. So for P we have the units meter square, and for Q we have the units MS minus 2. So that is option B. B is the right answer. Alright everyone, another paper 1 question. You're provided with this equation, okay, and they have explained the quantities used in the equation. For example, CD, they are saying CD is just a constant, it has no unit. It is used to compare drag on different cars at different speeds. It is given by the equation. F is the drag force, F is force here, rho is the density, okay, A is the area of cross section, alright, and V is the speed of the car. Find the value of N. So you need to find the unknown power. Alright, so from the same thing that we studied already, what we can do is we can rearrange to make the unknown thing the subject. So Vn, if you rearrange it for Vn, that would be 2F divided by CD times rho times capital A. Okay, and then you can skip CD from here because it has no unit. You can forget about this one. Let me just highlight this thing. We'll not be using it for the calculations. We need to find the units of we need to find the units on the right side, because on the left side we know that speed would be in meter per second. So meter per second to the power n equals 2. 2 is once again a constant number. You can skip this from the calculations. Force would be written as kgms minus 2. Now once again, those who don't know, you can apply the formula meters force equals to mass times acceleration. From there we get the base units. We studied that in the first lesson. Divided by rho represents density. Density is kgm minus 3. A represents cross-sectional area. Area is meter square. Kilograms cancelled away with kilograms. Let us combine the meters. So for meters we have power 1 from here, plus 3 from downstairs, minus 2 from downstairs. Alright, anything coming from downstairs from here, their power would be changed. It would be reversed. The sign would be reversed. Times s minus 2. So 1 plus 3 you get 4, 4 minus 2 you get 2, m2 s minus 2. So you have ms minus 1 on left side and you're getting m2 s minus 2 on the right side. What if I write m2 s minus 2 as ms minus 1 raised to the power 2? Don't you get the same thing? I mean, meter square per second square can also be written as meter per second, the whole square of it, because we can compare the coefficients only if the bases are same. So now the base from here on the left side, the base on the left side equals to the base on the right side. Now you can compare the coefficients, exponents, that n would be equal to 2. So n equals to 2 is the right answer for this one. Alright, here we have another question and the last one for today. V equals to k times delta p over rho and raised to the power n, where k is a constant that has no units. Find the value of n. Okay, we can do it. V represents the speed, so speed would be measured in meter per second. I'm just inserting the units one by one of all the quantities. Speed is in meter per second. That equals to k is a constant and has no unit, so you forget about the k. Delta p is representing the pressure. For pressure, the base units are, we did it already. Even today, the units are kg m minus 1 s minus 2. Alright, I explained pressure in the first lesson, in the first video. You can check out that one if you're not clear with this. Divided by rho stand for density. So density is kilograms m minus 3, kilogram per cubic meters. And this whole thing raised to the power n. Now let's do some cancellation if possible. So kilograms cancelled away by kilograms. So we are left with meter per second equals to m minus 1 plus 3, because minus 3 coming from downstairs would be plus 3. M minus 1 plus 3 would be minus 1 plus 3, 2. S minus 2, because there's a single s over here. So ms minus 1, we need to compare the bases, so we have to make sure that the base on the left side and the base on the right side is same. So we'll write this one as ms minus 1, and m2s minus 2 can be written as ms minus 1 raised to the power 2, and n is there as it is. All right, so this whole thing is written as ms minus 1 raised to the power 2, and there was another exponent n that would be written as it is. All right, exponent of an exponent, they are multiplied. From here, what do you have? The exponent of this is 1. If there is nothing above the brackets as the exponents, it is 1. So we can write that the base on the left side and the base on the right side is same, and if the bases are same, then their exponents can also be equated. This thing equals to this, 2n equals to 1, and that leaves you with the value of n, which is 1 over 2 or 0.5. So A is the right answer for this one. Alright, so that was the second part, everyone. In the next part, in the next video, I'll start off with the topic estimation of physical quantities, and I'll also solve some of the past paper questions from that topic. Make sure you have subscribed the channel and do not forget to like and share.